Okay, this is the last vodcast in this series of writing reactions in this unit. And what we're going to do in this vodcast is just put this all together and do a bunch of examples of how to write reactions when they're not all in one specific category. So for each of the following examples, we're going to do a number of things. We're going to determine if the reaction happens or not, and if it doesn't happen, we'll put an NR for no reaction. We're going to balance all of the reactions after we've written the products. We're going to identify what type of reaction from the 5 that we went over, and we're going to indicate the states of matter in each of those reactions also. So these are all going to be from your practice packet. So if you haven't printed that, I certainly hope you have by this point. But anyway, if you haven't printed it, print it, and we will start going over these. Okay, if you look at the first one here, we've got 2 compounds. So this is going to be a double replacement reaction. So what we're going to do is we're going to write the double replacement reaction, determine if it happens, but we're also going to write the net ionic equation. So if when I'm going over these, if you're having trouble with a specific type, then go back to the vodcast for that type and watch that. I'm not going to go over all of the specifics. In other words, when I say that sodium chloride is soluble, so we'll give it the AQ designation, if you don't know why I said that or where that comes from, go back to the double replacement vodcast and watch that vodcast. So it's a double replacement. Silver nitrate is also aqueous. We're going to write the products. So cations switch. So the first product is sodium nitrate, which is aqueous because it's soluble, and then silver chloride, which is insoluble, so it gets the solid designation. Let's make sure it's balanced, and it is. Since it's double replacement, what we want to do is write the net ionic equation. Now we have aqueous, 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 and solid. So something changes to solid, so we know this reaction happens. So the next step here, let's write it in ionic form. We have the sodium ion plus the chloride ion plus the silver ion plus the nitrate polyatomic. Sodium nitrate is aqueous, so we'll write those ions. And then our silver chloride is solid, so we will leave that as a compound, silver chloride. The sodium ion does not change, so we cross that out. It's a spectator. The chloride we're going to keep because as a reactant, it's an ion. As a product, it's part of the compound. Silver ion we'll keep also because it's part of a product, or I'm sorry, it's part of a compound as a product. The nitrates, we cancel those out. So our net ionic equation here is written there. Okay, we look at the next compound and we see that it's a single element and a compound. So iron is a metal, so it's going to replace the metal. Now you would need to be told the charge on iron, so let's assume it's 3 plus. Again, on a test or something, you would be given that information. So iron replaces copper, forms a compound with the sulfate. That is a 4. I have to start writing my 4s better. So the 3 goes behind the sulfate. Sulfate is 2 minus, so its subscript goes there. And then we have copper by itself. Let's balance the equation. 3, 3, 2 irons, so we'll put a 2 there. Now iron is a metal. It's a solid, because if you think back to your periodic table, most metals are solids except mercury. Copper sulfate is aqueous. Sulfates are aqueous or soluble, with some exceptions, copper not being one of them. Iron sulfate is also aqueous, and copper is a metal and it's solid. All right, let's take a look at some more examples. We've got a hydrocarbon, carbon and hydrogen reacting with oxygen. So you should recognize that as a combustion reaction. Combustion reactions, the products are always carbon dioxide and water. Now we're not going to write the well, I guess we can write the subscript. The C4H10, one of the reasons I hesitate is because we haven't talked about subscripts of hydrocarbons. So what we're going to do is just say that's a liquid. And we're not going to go into the description of why. We'll save that for a little bit later. Oxygen, you know, is a gas. Carbon dioxide, you know, is a gas. And we said that liquid water is a pure liquid, so that's going to get the L designation for liquid. Now let's balance it. We've got 4 carbons, 4 carbons. We have 10 hydrogens, so I'm going to put a 5 there to give us 10 hydrogens. Now let's balance our oxygens. We have 5 and 8, which is 13. Now what you're going to notice is there's no whole number to balance our oxygens there. So when you have that as the case, one of the tricks you can do is double that coefficient, and double that coefficient. Go back and rebalance the hydrogen, or the carbons, I'm sorry. So we have 8 carbons and 8 carbons. Now balance your oxygens. We have 16 and 10, which is 26. So we can put a 13 in front of our O2. Okay, the next one, we've got 1 reactant. So that has to be a decomposition. So we're going to break it up into its parts, magnesium and oxygen. But now remember, oxygen is a diatomic, so we write it as a diatomic. Magnesium oxide is a solid, magnesium is a solid, and oxygen is a gas. Okay, now the next one we have lithium and chlorine. Now there's 2 reactants, so you could think, well, maybe this is a single replacement, but you have to have a compound for a single replacement. Now even though chlorine is a molecule, when we say compound with single replacement, we mean an ionic compound. So this has to be a combination. So when lithium and chlorine come together, they form lithium chloride. Lithium would be a solid, chlorine is a gas. Think back to that periodic table that showed what elements are solids and gases and liquids. And then lithium chloride would be aqueous. Okay, let's take a look at a couple more examples. Here, the compounds are given in sentence form. So copper 2 sulfate, remember that would be copper with a 2+ charge, sulfate, and that's aqueous, is added to iron. So let's assume again this would be iron 3. So we've seen this reaction a number of times. Iron is solid, so we have iron 3 sulfate and copper. And we said iron does replace copper, so this reaction would happen. And again, that is a 4. I don't know what my problem with 4s is. That's aqueous, and copper is a solid. Okay, octane is burned in air, so that means it's undergoing combustion. Remember, combustion and burning are synonyms. So C8, H18, the other reactant has to be oxygen, and the products are always carbon dioxide and water. So again, we'll say that's an L. Oxygen is a gas, carbon dioxide is a gas, and H2O is a liquid. Let's balance it. 8 carbons, 18 hydrogens, so that 9 will make that 18 hydrogens. Now we have 16 plus 9, which is 24 5 oxygens. And again, we have that situation where there's nothing to multiply that to make it 25. So let's double that and make that 16 and 18. Let's rebalance our carbons, which automatically balances our hydrogens. Now we have 32 plus 18, so that's 50 oxygens. So we are going to put a 25 there. And that is not unusual to have large coefficients in combustion reactions. Let's look at the next one. We've got aluminum chloride. So we have aluminum chloride decomposes into its elements. So that's going to break up into aluminum and chlorine. Now remember, chlorine's by itself, so we write it as a diatomic. We're going to balance it by putting a 2 there and a 3 there to balance the chlorines, and then we'll put a 2 in front of that aluminum. Okay, cesium hydroxide. We have CsOH. Cesium is 1 plus. The hydroxide polyatomic is 1 minus. Is heated. Now notice, it doesn't say is burned. If it said that was burned, we would react it with oxygen. But when something is heated, it simply undergoes a decomposition. So now what we're going to do, we would write that as cesium plus the hydroxide polyatomic. Now we have a little bit of a problem here. What we're going to do is write that as cesium 1 plus and hydroxide 1 minus. This is one of those situations that would actually decompose into other products. But what we're going to do to keep this simplified is we would say it breaks apart into its ions, even though that's not exactly what happens there. So if you have a decomposition and you don't know what the products are, again, remember, what we're going to do is break it up into the things that form it. Okay, we have aluminum. Oh, we just did that one in the last one, so let's cross that out. So we have potassium and bromine are reacted. Potassium, bromine is diatomic, it's by itself. So when those two come together, they're going to form potassium bromide. +1 plus minus, 1-to-1 ratio. Let's balance it. And again, that would be solid. Bromine. Now, bromine, what we're going to do is we're going to write that as a gas. Now, again, you would need some additional information to determine whether bromine is a liquid or a gas, but we're writing it as a gas, and we're going to write potassium bromide as aqueous. And again, when we have situations like this on an exam or in a lab situation, we would talk more about those subscripts. We're really mostly concerned about subscripts when it comes to double replacement reactions. Okay, so there are some examples of how to write reactions. You want to do as much practice with this as possible. Do the practice in each section on the Moodle site and do the problems from the book. And if necessary, we'll do some more vodcasts to show some more examples of how to do this.